That was a bad idea. I really dislike videos that start this way, handheld, wandering around, just talking in the background. But there's something that needs to be done to this truck that really can't wait. Trick is going to be making it so you can see this. And getting light on it at the same time. So the original Dana 30 axle has something called CAD. I think it's connected axle disconnect or something silly like that. Anyway, it's a feature that nobody asked for, but we got anyway, probably to save money. And a million people have showed removing this on YouTube, but this is just an opportunity for me to explain why we're doing this. Okay, this was a tie wrapped up there anyway. The CAD is what connects this half or portion of the passenger side axle to the spindle. When it disconnects, even if it's in four-wheel drive, there'll be no drive to the front axle because it's an open diff, so it just spins this one. My CAD was working, and then I took it out on my little test track, and of course the CAD failed, which meant I really only had one-wheel drive because it's open diff in the back, and I ended up winching myself out, which was great fun. But that's not what this is about. This is about, I'm going to make this so it's always engaged, and that's not a 10mm. Wonderful. So let me go get another socket and we'll find out what's going on there. Probably restart the video too. Most people will replace the entire axle, the solid axle. I'm just going to disable this locket so the axle is locked all the time. I know it's not as strong, but this axle is not staying in very long. I have a Dana 60 or yeah, something like that ready to go in soon. So as with the rest of this truck, corporation couldn't figure out if they wanted metric or SAE. This is a 7/16, and a lot of the truck is metric, some of it's not, so you have to carry everything. That's one of the changes that's going to be made as I build all of this. It's all going to be metric when I'm done as much as possible. Okay. Okay, washer. Holy crap, washer. And I did not drop any of the washers in the grass, which is nice. Every tool is a hammer. Yes, I'm catching that and dripping it all over myself. All right, this is a CAD module from a 1986 Dana 30, which is different than the 87s and up, it seems like. They're vacuum actuated, they're both vacuum actuated, but the newer ones have an electrical sensor on this end of the housing, where this is somehow has a third vacuum that's actuating this switch on the dash that says that four-wheel drive is active. So it's a slightly different design along those lines, but it still operates by vacuum. This shift fork moves based on vacuum. It's connecting two pieces of a split shaft together so that they both rotate together instead of rotating separately. The reason that they had it originally was arguably for fuel mileage. The problem is if this does not actuate, if it doesn't come over, the differential sees this axle spinning here, or the opportunity for the axle to spin with no load, because it's not connected to the wheel. So it just spins that axle, and the wheel that's actually connected to the ring and pinion just free floats. That's how open differentials work, right? What I'm going to do is I'm going to force this to stay actuated. I'm going to stick it over here. I'm going to put spacers in here so it can't slide back. It's going to maintain actuation. I'm going to do it a cheap way because This is all going away anyway when I put the Dana 60 in, and it's not going to hurt anything. First, I need to take this apart, and to take it apart is just like the newer models. There's 3 snap rings in here. There's a large one and 2 small ones to pull this actuator out. So the first step before I disassemble is to get a measurement here to find out how far that has to go. So to find out the space on that, since I can't get a caliper far enough down in there to get it accurately, just taking a socket, something to fill that space. And this 7/16 socket, the icon fits in there. So we just figure out the outside diameter of that. It's 0.6205. Okay, that's 0.6205 in inches. Why I didn't do it in millimeters, since I'm complaining about them using SAE sockets, I don't know. I don't have a good excuse for that. Do I want to pull this one out first? No, I want to pull this one out last. Do I? To pull this one out first. If I can. So we can do that. Let's not lose it. The goal is to not lose it and not put a pick in my hand. That's gonna go flying. If I can get it. Let's go this way. Two things right off. Right off. Okay, that worked. Can you help? I can. Hey, not damage goodness. Oh, let's dig this one out. That's where we're going. Okay, want to be difficult? This morning I choose violets. Sorry about that, boss. What can we see here? Mess you all up, huh? Okay. Alright, that seems to be working. Sort of. That's not good. Gotcha. Are they the same? They are not the same. Interesting. That's why it didn't work so well. So this one, which is the middle size one, goes on inboard side. This goes to the middle, and this larger one that's over here is going to go to the outside. Let's see if we can dig that one out. No, that's... All right, so this one's probably out. Gotcha. That was much larger. So we know they're not going to fall apart. Now this should be pressed in, sort of. There's got to be a way to get that out. That shaft runs all the way through. I don't want to hammer on it right away. Since I don't care if this thing works or not, that's a plastic. I'm going to do something off camera here. I'm going to go put this in the vise and see if I can break this loose. Actually, I'm going to spray it first. See if I can loosen this up. Put some PB Blaster on it. I'll get back to you on this. Okay, off camera, I chose violence to separate this. I went first, looked at Rock Auto, and saw I could buy this piece, which really surprised me. You can buy, you know, a 1986 part off of there in the correct configuration. Well, what looks like the correct configuration. But more importantly, I was able to look at pictures of it and see that it didn't look like it was keyed, which it wasn't. So then I placed this piece in the vise, in the jaws of the vise, the where you would place pipes and that sort of thing, to support it without cracking it, hopefully. and I didn't crack it, and then just put a pry bar against this section right here. You can see the mark, and tapped it to get the piece out. So there's quite a bit of corrosion in there. That O-ring is probably junk, but that's okay. So I'll clean these parts up. I'm gonna check to see if I have a fresh O-ring for that. I think I might not even need one, but we'll find out. I'll pop it off. If it breaks, then I know I'll need one. And with that, I'll update you once I get some parts and we start putting it back together. Okay, so we built a spacer that fits in between that E-clip ring or slot and the main body. That will keep it from moving around at all. Next trick, see if we can reassemble this mess. This might be a lot of fun. Let's see how tricky this is. This could be interesting. This in there. Choose violence. Need to wedge this up somehow. There we go. Let's see where what there it goes. That was a bad idea. It went flying somewhere over there. It's behind you. Okay, found the clip. See if I can not lose it again. I imagine there's a tool for this. It's pretty safe to say I'd be interested in buying it. All right, so here. We'll try to rip this. Rock and roll. So this is the piece that slides back and forth to connect the two axes. You can see it's broken in the middle. This slides over. Let's get this to slide over. There we go. So that's joined now. All right, let's see about how difficult this is to get to line up without knocking over the camera. Okay, it's no fun.